Hello. This is our presentation on taxing tipping culture, a Bayesian multiple linear regression approach. This is by Alex and Stephen.
So our research question is looking at what kind of factors influence passengers' behavior in tipping when riding and like the yellow cabs in the city. And basically, yellow taxis are like they're they're a iconic part of New York City, and the drivers earn most of their wage through like additional tips based on the total trip amount. And then we're going to use a Bayesian approach by first getting prior knowledge, and then our second step is grabbing like a data and likelihood, and then finally we'll do a posterior calculation and analysis. So some prior is that a good practice for tipping cab drivers in the city is 20% of the total amount after all the extra fees and taxes. And then we're going to use a sample 2022 data set to kind of extract expected coefficient estimates and their precisions to use in our MCMC. And then so we kind of assume that the taxi data for 2023, which we use for our likelihood, will follow similar patterns that we see in 2022. And then we're going to run a multiple linear regression using the tip percentage as our outcome on various features that you'll see on this slide. And then we'll use variations of features and encodings, such as one hot encodings and cycle encodings for date-related features. And then we'll rerun the multiple linear regression fitting on multiple combinations of the features. And then here's just like some code that we use to run our prior analysis and to get the parameters.
And then for posterior analysis methods, we're going to utilize JAGs to simulate different MLR models by drawing from normal distribution. We have some code of several models we've used. We also perform MCMC diagnostics to ensure that our coefficients converged. And then we also evaluate the mean, median, and credible intervals. And then lastly, we're also going to carry out cross-validation to find our best fit model. And more on that is coming up. So for cross-validation, we tested different MLR models using the testing data set that we extracted beforehand. And we found that the SSPE values were 11.85 and 38.58. And we deemed that the model with the lowest SSPE would be the best fit for the actual data set. And this was just how our final model looks like. And then additionally, we have some diagnostics from the final model that we use. We also utilize thinning within to make sure we converged. And then some results that we got was this would be the optimal cab ride to maximize tip percentage. So an optimal cab ride would have a driver where they have a low passenger count, a low trip distance, and then a high trip fee. But this one is less certain because the 95% intervals go between negative and positive. And then also a trip that has no airport fee and a shorter trip duration usually has higher tip percentage. Here additionally is like a posterior predictive check. The red plot is going to be the actual data set, and the blue is how our prediction sort of looks like. And I believe that is it for our presentation. Thank you.